So let's try this problem. So I've got an expansion corner. Looks like this. Has a deflection angle that is equal to 23.4 degrees or 23.38 degrees. I have a Mach number to start that's equal to 2. And I have a pressure to start that is 0.65 atmospheres. And the temperature of 510 Rankine. Okay, I'm going to have an expansion fan. And I'm going to have some sort of Mach number afterwards, some pressure afterwards, and some temperature afterwards. So how do I figure this out? Well, first I need to figure out, what my Mach number is after the expansion fan. So for that, I would have to go to the Appendix C and look for a Mach number of 2. Okay, so this is Appendix C. I'm going to scroll down. This is a Mach number of 2, and my Prandtl-Meyer function angle will be 26.38 degrees. So I found that right there. It's right there. Very careful, don't choose the Mach angle. That's completely different. I need a Prandtl-Meyer function angle. They are not the same thing at all. Okay, so 26.38 degrees. So I'm going to do that. So M1 equals 2, which means Prandtl-Meyer function is equal to 26.38. I need to get my second Prandtl-Meyer function, and to do that, I add my deflection angle. So that's equal to 23.38, which gives me a second angle of 49.76. And from that, I'm going to get M2 by once again going back to that same appendix. So, 49.76, in my opinion, is pretty dang close to 5. So I'm going to say that it has a, I was in the wrong column entirely. Sorry. 49.76 is exactly the same. Whoa. Whoa, look at that. It's like they planned it. I get a Mach number of 3. Okay, so this one is equal to 3. Now for everything else, I have to go to Appendix A. So I need to go to Appendix A and figure out all my ratios. Like I need P naught over P. I would also need T naught over T. And I'll need that for a Mach number that's equal to 2 and a Mach number that's equal to 3. So what is it in both these cases? And remember that because this is isentropic, T naught 1 is equal to T naught 2, and P naught 1 is equal to P naught 2. We need to know that because it makes it a lot easier on us. Okay, so let's go to Appendix A and get all of those values. Now, let's see here. Yeah. I'm going to pull it up actually on a different screen so I can write them down more easily. Okay. So for 2, Mach number of 2, it's 7.824. This one right here is 7.824. And this is 1.8. And for 3, this would be equal to 36.73. And 2.8. Not too crazy. Okay, so let's find everything. So first off, T2 would be equal to T1 times T1 over T01 times T, gotta make sure I do this right. Oh goodness, I'm mixing up my ratios already. Times T01 over T1, there we go, times T02 over T2. I need to remember that those two are the same. So those cancel, and so I should be left with T2 at the end. So this is going to be equal to whatever my temperature was, which was 510 Rankine. I'm going to then multiply that by T01 over T1, which is 1.8, and then multiply by that the inverse of the other one. So that would be 1 over 2.8. Okay, in order of saving time, I'm going to wait for a minute before I plug everything in. I'll get that P2 is equal to P1, P01 over P1 times P2 over P02. Those two cancel. So that should work out fine. And that would be equal to my initial pressure, which, going back up here again, was 0.65 atmospheres, not 65. And then P01 over P1 is 7.824. P02 over P2 is 36.73, which is, I need to invert that. Okay, and so now I can actually plug those into my calculator and see what my answer would actually be in this case. So I would get that my temperature is equal to 327 degrees Rankine. Pretty cold. And then let's look at my second one. My pressure would be equal to 0.138 atmospheres. Now, if you're wondering what like P02 and all that stuff is, well, P02 is equal to P01, which would simply be equal to P01 over P1 times P1. So that's 7.824 times 0.65. Which is 5.085 atmospheres. And the last one is simply what is T02. Similarly, T02 is equal to T01, which is equal to T01 over T1 times T1. And so that'd be 1.8 times 510 degrees Rankine. Which is 918 degrees Rankine. Woo! Okay, so I got all the values after the shock wave doing this. Mach number of 3, got the temperature and pressure, and the total temperature and pressure. We did it. Cool.